Hey everyone, welcome back to my daily coding series. Today is day 87. So I'm going to try an interval problem today called merge intervals. Alright, so interval problems I don't have much experience with, so I'm just going to try my best. I'll probably give it like 30 or 40 minutes and then I'll look at the solution and then I'll come back and implement it. But hopefully I can do it without the solution. Okay. So let's look at this problem, merge intervals. So we are given an array of intervals. So this is kind of a 2D array, somewhat. And we want to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, intervals are non-overlapping if they have no common points. For example, 1, 2, and 3, 4 are non-overlapping, but 1, 2, and 2, 3 are overlapping. Are the intervals like sorted, it looks like? Doesn't say that they are. Okay, so I'm just going to assume that they're sorted for now, and if they're not, I can sort them later. So, alright, so if we look at the first example, I'm just going to walk through it and make sure I understand the idea. Okay, so in this case, we see that 1, 3, and 1, 5 are overlapping. So then we condense it into 1, 5. We merge it. And then 6, 7 is not overlapping with anything. And then this is our final result. Okay, and in the second example, we have 1, 2, and we have 2, 3. So we see that this interval is overlapping because this 2 overlaps with this 2, so then we merge them into 1, 3. Okay. Another example would be, so if we change this to also have, let's say, 1, 6 in it. Let's say this was 7, 8. Then now we would combine the 3 of them into 1, 6. Okay, and if this was a 2, or a 2, we would still have it be 1, 6. Okay, so I think the idea, okay, so let me just look at the edge cases. So we can have, so every interval is of length 2. We can have up to 1,000 intervals. And what's start and end? Oh, the values in the intervals must be 0 to 1,000. So we're all working with positive. So it doesn't say it's sorted, so I'll probably just sort it. Okay. So I think the idea is you look at this second number, and while it's bigger than the first number of an interval, you keep going. And then yeah, so while it's bigger than the first interval, you basically keep going. And then once it stops being bigger than the first interval, or the end point. So, okay, so let's look at 3. So this is the end point. So we'll keep, let's say we have a pointer. So we'll keep moving this pointer while the end point of the original is bigger than the start point of the one at the pointer. So 3 is bigger than 1, so we'll keep moving it. 3 is bigger than 2, so we'll keep moving it. 3 is not bigger than 7, so that means we have to now merge all of these together. Right. Do I have to do it in place? I don't think we have to do it in place. So I think what I'm going to have is just have like a result. And then in this case, so I would add the start of the one that we started at, and then the end of the last one that we merged with. And then I would repeat the process with here. So we'd look at the endpoint 8, and then we'd keep moving it until 8 is less than the start of the pointer. And then, or in this case, it reaches the end. So then we would take 7, which is what we started with, and then the endpoint of I minus 1, which is 8. All right, so let me try that, and let me just see if that works with the examples here. So we're going to have a pointer, and then I'm going to remember like the start value as 1. And then while 1 is greater, no, while 2. So we actually look at 2. So like, and then it's like while end value is greater than start value of interval I. So we increment I, we see, and then greater than or equal to. So we see that 2 is greater than or equal to this one. So that means we merge it. Well, actually not yet. It means that we increment I. And then now we're out of bounds. So we increment from, so after loop, merge from start point to I minus 1. Yeah, and how do we merge? We create new interval with start. Okay, instead of start point, I'll call it just like start interval. Start is a bad word. I'll say first interval. Okay, so create new interval with first intervals start and I minus 1's, let's say interval I minus 1's end. So what that means is we'd create a new one with 1 and 3. So first interval start is 1 and interval I minus 1 end is 3. Okay, so let me write out some pseudocode for this. So it works with both the examples. So what we're going to do is we'll set I to be 0. We need to initialize the value. So I guess we could say like, I don't know if we'd call it pivot. I'm thinking pivot would be the end value. Maybe we could say like first start and first end equals interval of 0. And then we can say, alright, we could clean this up a little bit, but so I'm thinking we would say while I is less than length of intervals, this isn't really pseudocode, but it's kind of helping me get through it. Python sort of is pseudocode almost. Okay, so while I is less than the length of intervals, and so what's our continue condition is if first end is greater than intervals of I. Right, so in this case, so I set I to be 1 here, which I think makes sense because we don't need to check anything against like the 0 against itself. So while in this case 1 is less than 2, it is, and first end 2 is greater than or equal to intervals of I of 0. So the first of the interval. And then what we want to do next is increment I and do it again. So just keep doing that. I think we might need 2 loops because this is one merge basically. Okay, so then we merge. And we keep doing this whole process, yeah, so I think we actually need 2 loops because like in this case, in the first example that I showed, right, so we would merge these. So we'd start with I as 1, then okay, 3 is bigger than 1, so we'll move up. And now 3 is bigger than 2, so we'll move up. 3 is not bigger than 7, so we're going to merge these into 1 to 6. And let's say I have more intervals though, so let's say this is like 7 to 10, and this is 8 to 9, and then we have like 10 to 12. Right? So now I basically need to redo that whole process. The program doesn't terminate here. So this whole thing should be in a loop. So I think what we do is we initialize, so let's make this J. I don't know, do we need 2 pointers? I'm just gonna call it J for now, just to help distinguish in my mind. They might be the same pointer. Okay, and then so I'm gonna initialize I to be 0, and then we say while I is less than length of intervals. Yeah, so I would start at 0, and then so we'll say, I think what we say is first start, so like the start point, and first is kind of, I'll call it like the what's a good word, like head maybe? It's the head of the merge. Okay, so the head I'm defining as the first interval that will be a part of a merge. So that we know that the head start will be guaranteed to be the start of the new merge. Okay, so we get the head, and then I think we can define J as just I plus 1 instead of 1. Right. All right, so we'll do that. We merge here. So, sorry, not J plus equals 1. J equals I plus 1. So we get our first interval. We define J. And then what do we do if I gets out of bounds? I guess that's, when do we increment I? We increment I after we merge. No, we don't. I don't think we... Okay, so this is a bit problematic because... So remember, before I said, we keep going, and then once we check this one and it's not, so 3 is not greater than or equal to 7. So then we merge from the head to I minus 1. So merge from head to I minus 1. And then well, that's J. So I think I just becomes the new J. Or maybe I said that backwards. No, I think I said it right. So then here you'd say that I equals J. So this is where we want the new start point to be. Yeah, I don't even know. I think it can actually just be the same pointer because we do this. But I'm just going to keep it as 2 for now and not oversimplify too early. So then at this point, so we merge them, and what that means is we just added that. And now, at this point, we can redo the whole process. So head start and head end are now 7 and 10. J equals I plus 1, like this. And then we keep Yeah, and then we just basically do it again. So while it's less than the length of intervals, which is true. Okay, I'm going to delete this. So yeah, so I'm just going to kind of like walk through the example here. So we know that this part works. So now we just did j equals I plus 1. This evaluates to true. Head end is 10, and it's greater than. So then we're just going to, j is just going to go up by 1. And then j is 0, 1, 2, 3, 4, 5, which is less than 6. And head end 10 is greater than or equal to 10. So then j goes up by 1. And now this evaluates to false, which means that we merge. This should be j minus 1. So we merge from head interval to j. So in this case, that would look like we'd do 7 to 12. 7 to 12. Okay. And now I equals j. So then this would fail. And I can never, yeah. So I only fails when j fails. Okay, so I'll try this sort of thing. Like I said, the pointers, I might not need to separate those. Also, the sorted assumption is still up in the air. Okay, so let's try this. So well, basically, my pseudocode's pretty Pythonic already. So I'll just kind of type this in. So we want it to be intervals of I, and that's what it's called, right? Intervals, yep. And then j gets set as I plus 1. And then first we do the bounds check. And then we're checking if the end of the head interval is greater than or equal to the interval at the pointers and then its start position. We want to just keep doing j, and then once we go out of bounds or we don't need to merge anymore, then we merge. So I'll just put that as a comment for now, and then I equals j. Okay, so the merging itself, so like I said before, I'm just going to have a result array, and then I will append a new interval, which will be equal to head start and intervals of j minus 1 of 1. So in this case, that would be 12. So wherever j is, we want to go to the interval before it and then take the bigger side of the interval, which is 1 index. Okay. And then we can return the result. All right, so this works under the assumption that it's sorted already. I think everything else is looking good though. Okay, so let's see if we pass the first test cases. All right, we failed this one. Okay, so it's not sorted. The intervals are not sorted, which makes sense because it doesn't say that in the problem. So this whole solution expects it to be sorted, so I think I'm going to sort it. Yeah. So there's two things. So if you just say intervals.sort, I'm not sure if that will, can I use that one as a test case? Use test case. Okay, so I think if I say intervals.sort, it will work for this test case. But let me just, and it might work for the whole thing, but let me just articulate the thought. So if we have, like, for instance, 1, 7, 1, 6, I need this to go to 1, 6, 1, muted my mic there, 1, 7, and I don't know if it does that, so hopefully, yeah. Okay, so if we have, let's say we have a list, which we define as 1, 7, 1, 6. And now I want to sort that list. All right, it does do that. Yeah, that's fine then. I basically just want it to get sorted by the first number and then the second. So it looks like it does actually care about the second number. So let's see if that does the trick. Okay. So this is a case I didn't consider where the endpoint of the interval supersedes that if the endpoint of the first interval is greater than the endpoint of the second interval. Yeah, so when I merge, I just always assume that this one is actually bigger, but that's not true. So here it would be the max of head end and this. Hopefully that would fix it, because now it just picks the bigger one. All right, now we have another issue. So this looks like, let me use this as a test case. So let me make sure it's not, I'm not totally convinced about the sorting. So I just want to make sure that it's sorting how I want it to. Okay, that looks good. My output is 0, 4, 3, 5. And of course it should just be 0, 5. So this is being sorted how I want. All right, so let's trace it and understand why we have. Okay, I'm a little convinced on the sorting now. Okay, so the problem here obviously is that we are ending early. So we'll say, okay, 0, we'll say 2. Wait, it wants me to do 0, 5. Oh, all right. This makes sense, I guess. So yeah, so I'm only looking at 2. But the problem is, so once these two merge, now the rightmost endpoint is actually 4. So instead of checking okay. And I think this might solve this other problem too. So if we have so I think we need something called current end. Which will initialize to head end. And then, so when we go up, so we see, okay, 2 is greater than the next one. So I think instead of head end, we should say if the current end is greater than the next one, then we want to set possibly, I would say current end should be the max of itself and intervals j of 1. So in this case, and then here we would just do current end. So, all right, so let me trace this for a second. So 0, 2, so current end is 2. J is less than, yep, that's not out of bounds. Current end is 2, which is greater than 1. 2 is greater than 1. So now current end becomes the max of 2 and 4, which is 4. And J goes up now. Okay, so that should work. All right, awesome. Okay, for some reason I feel like I can't see any of my code right now. Okay. Yeah, so another thing is, do I really need I and J? Let me just try it, because I'm thinking that I kind of don't. So in that case, I would just need I plus equals 1. And then this would be I. Because we never really use I and J at the same time, is what I'm suggesting, right? We never use I and J at the same time. Yeah, we just use J in this section. The only time we use them at the same time is when we make one equal to the other. So we don't need both of them to do that. So I would say we probably don't need to have 2 pointers. Do I have a J anywhere? Okay, 3 commented out J's. All right, let's see if that does it. Yeah, I forgot to increment I right there. This we don't need. This we change to I. J equals I plus 1 is the same as I equals I plus 1, which is I plus equals 1. All right, yeah, so we don't need 2 pointers. I think it was just helpful for me to distinguish that in my brain, just because we have these 2 loops here. So I think this looks like a good solution. I mean, maybe you don't have to sort it. Okay, so there's some algorithm for it. Are they all n log n? This is n plus m. What's n and m? What's m? Oh. Length of the array, and m is the maximum start value. Okay. Yeah, I feel pretty good about this. So he did like the lambda sorting. I was thinking of doing that, but I think this works fine for my case at least. But yeah, I feel good with this. So he only has 1 loop. This is still, like, the most expensive part of this is actually the sorting. This is still O of n. Believe it or not. Just because the pointer only goes up. So, alright, let me, how can I do this? 1 second. Alright. Just bring this down here. Alright. So I'm going to type it into LeetCode and see if it works. But yeah, that was a good problem. I remember it being like, so I had a kind of like a take-home assessment with it, and I remember it being really hard, but I was thinking about it last night and this morning, and it didn't seem like it would be that bad. All right. Yeah, great. So it looks like it is pretty fast. The memory, what memory problem is there? This sorts it in place, I think. Oh, it's probably because I have the result array. Yeah, maybe it might. Is it supposed to be in place? Just says return an array. Yeah. Okay. Well, thank you guys for watching. That was day 87. I'll see you guys tomorrow for day 88. I might start going crazy with it and doing it twice a day, just to like really get sharp for the interviews that I have coming up. But yeah, thanks for watching.